In this lecture, we will be seeing how to solve matrices or one-dimensional problems using the penalty approach. In the previous lecture, we learned about how to solve a one-dimensional problem using elimination approach. In that approach, what we do is we find out the node or nodes at which the displacement is 0, and corresponding to that node, the degree of freedom corresponding to that node is eliminated from the global matrix. So in the penalty approach, what we do is we take a constant C which depends upon the maximum of the values from the global stiffness matrix and multiplied by 10 into the power 4. So for example, if we have a matrix which is like this, okay, and say 9 is the maximum value. Here we see we've used this mod sign, which means irrespective of the sign, okay, the maximum value, we are taking into consideration only the value and not its sign. So in this case, the maximum of this Kij, meaning any number from this K matrix, the global stiffness matrix. So whatever the value, we have to multiply that by 10 into the power 4. Okay, so in this case it would be 9 into 10 to the power 4. So the idea is to get the maximum value and then multiply it by a very large number of the order 10 into the power 4, and this number then we have to add to the degree of freedom which is fixed. Let us take an example to demonstrate this. So I have a stiffness matrix which is like this: 2 into 10 to the power 6 minus 2 into 10 to the power 6, 0 minus 2 into 10 to the power 6, 4 into 10 to the power 6 minus 2 into 10 to the power 6, 0 minus 2 into 10 to the power 6, 2 into 10 to the power 6. Now this problem is something of an inverted shaft, okay, like this. This is the axis. So this is node 1, node 2 and node 3. Node 1 is fixed. We have to find out C. So if we see this matrix here, the maximum value is this, that is 4 into 10 to the power 6. This we have to multiply by 10 to the power 4. So C is 4 into 10 to the power 10. So since the node 1 is fixed, we should add the C value to the first element of the matrix so as to balance the C value which is very large. Okay, so K will be, we have to add it here, so it will be 2 into 10 to the power 6 plus 4 into 10 to the power 10. The remaining terms remain unaffected. So here we have 3 equations and 3 unknowns. These 3 equations have to be solved simultaneously to get the values of the 3 unknowns Q1, Q2 and Q3. When you solve a problem using this penalty approach, you will notice that, say for example in this problem itself, the value of Q1 will be much lesser as compared to the value of Q2 and Q3. This is because our problem was like this and node 1 was fixed. So actually the displacement at node 1 has to be 0. So for example, you will get some answers like this. So this is Q1, Q2 would be say 1.5 into 10 to the power minus 4. This will be say 1.6 into 10 to the power minus 4. This is just for an explanation. So look at this order here. This is 10 to the power minus 4. This is also 10 to the power minus 4, whereas this is 10 to the power minus 8. Okay, so when we add a large number to the degree of freedom which was fixed, okay, so in this case it is node 1, this is basically done so that the answer is almost a 0 on Q1. Next, after you find out Q1, Q2 and Q3, you are going to find out the value of sigma. Okay, that is the stress. So when you are finding out the value of stress, make sure that for Q1 you will be using this value. Okay, although this is almost equal to 0, do not use this value as 0, but use this very low number to get your stresses. So the formula for sigma would be, you know, something like E, B and Q. Okay, so you'll substitute for E, B and Q will be Q1, Q2. Okay, so you have to substitute this value, whatever less value you are getting, in the formula for the stress. That's all about the penalty approach. So when you're given a problem to solve in one-dimensional element, you either solve it using the elimination approach or using the penalty approach, depending on what is asked. If the question doesn't state which method you have to use, you use any method which you are comfortable using. Thank you.